So we are now finishing the 10th week. This is our 19th lecture, and we are going to finish the 14th chapter. As I mentioned, the test on the 14th chapter is going to be next weekend. So remind me, please, what are we up to?
We're on page 8.
We're on page 8. Converting between percentiles and scores. Okay, and z-scores. Okay, so yeah, okay. So let's recap a little bit. Okay, we talked about z-scores. We have a formula here for a z-score. Okay, what does a z-score do? A z-score essentially tells us how many standard deviations above or beneath the mean we fall. Okay, so if a z-score is 0, we fall directly at the mean. If a z-score is 1, we fall 1 standard deviation above the mean. If it's 2, we fall 2 standard deviations above the mean. And it gives us a method of comparing distributions that are not the same, like male heights and female heights, as we saw with Kanye and Kim last time. So what we're going to do now is talk about how to calculate the percentage of data that falls beneath any particular z-score. And the good news is that we don't do it ourselves. We have a table that does it for us. And you can find these online. You can just do a Google search for a z distribution table or a z-score table, and you'll see something like this pop up. And what this table is giving us is as follows. It gives us any z-score. These are all not any z-score, but these are the decimals, you know, negative 3.5, negative 3.4, negative 3.3, all the way to 3.5. And it tells us the percentage of data that comes below my z-score. So for example, if my z-score is 0.8, which is somewhere over here, it tells me that 0.7881% or 78.81% of my data is to the left, which means 0.8 would fall at which percentile? If 78.81% of my data is to the left, which percentile do I fall in at 78.8 at 0.8? What's the connection between percentage to the left and percentiles?
Are you talking about 68%? Wait.
I'm sorry, say that again?
68 or no?
Not 68. No. If I landed 0.8, if my z-score is 0.8 right here or so, that tells me that 0.7881 of my data, 78.81% of my data is going to be to the left of that point, correct? That's what this is telling me. The percentage to the left of my data point is 78.81%. What I'm asking is, what percentile am I in?
The 80th percentile?
No, it's the 78.81st percentile. This number is the percent to the left, and it's also the percentile. It's both. It does dual, it's a dual purpose value. The percent of data to the left is also the percentile that I'm in. So 0.7881% to the left means I'm at the 78.81st percentile. They mean the same thing. Okay, so let's refer to the previous example. What is the percentile for the height of Kim? So let's go back here. Anyone recall from last time, what was Kim's z-score?
Negative 9.6.
Negative, no, that can't be right. Negative 9.6 is really, really, really low.
0.96.
Negative 0.96 makes more sense.
0.96.
Okay, so now what we're going to do is we're going to go to our table and we're going to look for a z-score of negative 0.96. Okay, now we can't get that exact on this table, unfortunately, because this table only does, you know, for the first decimal, we have to the 2 decimals. But it certainly appears that it's somewhere between these two numbers, roughly halfway between them. Would you agree? So that means I look at these two numbers, which are the proportions, and I take the number that's roughly halfway between those. So what percentile approximately would Kim fall in when it comes to heights?
0.9, 90th.
No, 90th percentile means 90% is less than that value.
Okay, 18, 19.19%.
Not 0.19%. You can't mix those.
Out of 100, yeah. So 19.
Well, we want a number roughly halfway between these two numbers. What's a number roughly halfway between these two numbers?
7, 16, 7, I don't know.
13%?
No, halfway between 0.158 and 0.184.
16. 0.5. No, I don't know.
Well, why don't you add them and divide by 2? Let's see what people say.
That's a great idea.
I like that idea. How do we add them and divide by 2? Yeah, 16.5%, 70%, somewhere around there seems very accurate. Does that make sense? Yes, no, maybe so?
Kind of.
Well, I don't want kind of. I want yes, I get it. Kind of.
17%.
Can you? Okay.
Angela gets it. Huh?
Yay, Angela. Can you do another example? Let's get off.
Oh, sure. Let's do the percentile for Kanye.
Oh.
What was Kanye's Z-score?
Okay. Negative 0.67.
Negative 0.67. So let's just round that to negative 0.7, just as an approximation. Negative 0.7. If Kanye's Z-score is negative 0.7, then what is Kanye's percentile?
25%.
Well, it was negative 0.7, right?
Yeah.
So it's about, yeah, it's between negative 0.6 and negative 0.7. Negative 0.6 is 27 percentile. Negative 0.7 is a 24th percentile. Somewhere between 25th percentile, give or take, is right. Does that make sense?
Yes, I'm trying to apply this to my life in general.
Well, not everything we do in, not everything that we do in statistics can always be necessarily applied to real life.
Okay, forget it. That's it then. Bye.
Well, that's not necessarily where I wanted to go from here either.
Hey, Professor?
Yeah.
I'm sorry.
Go ahead.
We're adding the two numbers between 167 and 0.7, right? 0.1, what's it?
Are you talking about the Kim example or the Kanye example?
The Kanye example.
So Kanye,
add them and then divide it by 2.
Well, what was Kanye's Z-score?
Or negative 0.67.
Okay, which is somewhere in between this number, a negative 0.6 and negative 0.7, correct?
Okay, yeah.
So yeah, if I really wanted to be exact, I would get an online calculator or something that's a lot more exact than simply saying, oh, it's some number in between those two. But for here, we're just trying to get the idea behind it, which is It's somewhere between this number and this number, 25%, 26%, something like that seems right. Does that make sense?
Yep.
No, maybe so?
I just wonder like how then, like, never mind. I'm taking it and running with it. I was just trying to think like, okay, well, how does this affect decisions? But that's more than
well, the decisions that it affects, Lori, I mean, you know, you've had children, so I'm sure you've done situations where, you know, they were getting tested for their weight and for their height at different ages, and percentiles certainly played a role. If you're asking, you know, as I walk down the street, where do I see percentiles? Then the answer is you're not going to see them.
No, I was just saying that like it just helps me to understand why they get this data, but whatever, that's a whole nother elephant.
Well, what do you mean? Where they get what data?
I mean, never mind. It's too deep of a question. I can't verbalize what I'm thinking.
All right. Well, as we go on, maybe hopefully you'll be able to. We'll go from there.
Exactly. Sorry.
Okay. Okay, so here's another example. It says to identify students of high achievement ability, the LAUSD tests all second grade students using the Otis Lennon School Ability Test, the OLSAT 8. This test has a mean of 100 and a standard deviation of 16. Now, those are important values. Everything until now is who cares, but this is important. Mean of 100 and a standard deviation of 16.
So we're going to plug this into that little.
Well, hold on. To qualify, the student must have an APR, an age percentile rank of 95 or above. We have to have a percentile of 95 or above. Now, if a student is of low socioeconomic status, then an APR of 90 is sufficient. Okay, these are just the facts. The question is, what Z-score does a non-low SES student need on this test to qualify as high achievement ability? What a Z-score corresponds to getting a 95th percentile?
1.7.
Yes.
Boom. So the actual answer, because I happen to know it offhand, is 1.645.
Oh.
That just happens to be one of those numbers that I've heard so often because it plays a role so much. But essentially it's 1.645. That is the Z-score that corresponds to the 95th percentile, 1.645. And how about what score does that same person need to qualify? We've just ascertained that the Z-score is 1.645. But now the question is, what actual score does the student need to qualify? How do I figure out the actual score? Oh, God.
Compute and interpret the Z-score. Ask the question again. How do you figure out the actual score?
Yeah.
Not the Z-score.
No, we already have the Z-score, right? The Z-score
Yes.
is 1.645, right? The question is, how do we get the actual score?
We have to go back. Wait for it. Wait a minute.
I'll wait 2 minutes.
This test has a mean of 100.
Is it 0.78?
No, where are you getting that from? What's the
I looked
formula?
at the chart next to 0.8.
But where do you get 0.8 from?
I just looked at the chart and figured.
I understand, but why? Where does 0.8 coming from? That you looked at the chart and you picked 0.8. That's what I'm asking.
Right there, where it says 0.78. That.
Yeah, but where in this problem is it telling you to reference this row? Is what I'm asking. Why do you pick that row out of all the rows? That's what I'm asking you. Why that row?
Oh, it says what score on the OLSAT 8 does. So like I figured 8 would be 0.8.
No. That's just called the OLSAT 8. It's just called, it's the name of the test.
Okay.
That's just the name of the test, the OLSAT 8. So what's the formula for Z-scores?
2, 3.
Now, what's the formula for Z-scores?
Formula for Z-scores is X minus
The mean.
X bar over the standard deviation.
And what is the mean in this example?
100.
And what is the standard deviation in this example?
So it's 99 over 16.
Wait. They gave me the standard deviation. They literally said that the standard deviation is this. What is the standard deviation?
16.
16.
Just making sure you're paying attention, Professor.
I appreciate that. Thank you so much. That's so sweet. So it's X minus 100 over 15. Z equals X minus mean over the standard deviation, X minus 100 over 15. How do I go ahead and solve this?
It's 16. Standard deviation is 16.
16.
Thank you, 16, sorry, 16. So how do I go ahead and solve this for X? Here's an equation that has X in it. How do I solve it for X?
And then multiply it by 16.
Multiply both sides by 16. So let's take out our calculator and do that. 16 times 1. Oh, no, don't do that. So I get 26.32 is equal to X minus 100. And therefore, what is X? Add 100 to both sides, 126.32.
Bam.
Does that make sense?
So wait, let me back up. What z-score does a non-low SKS student need on this test to qualify?
So the z-score is 1.645. We got that from the table.
Yep.
And then the actual score we got from the formula for z-scores.
The formula for the z-score.
All right, okay, can you show that step by step because I'm lost.
Where's that noise?
Mute.
Okay.
So
So what's the question?
You multiply both sides by 16.
Right. So when I multiply this side by 16, the 16s cancel.
16, 10.
So I get 16 times this equals X minus 100.
Yeah, I didn't do that. Okay.
Right. And then I just add 100, right?
1.645.
Correct?
Yeah.
Okay, it's all good. Does that make sense?
Yes.
Okay. Taylor Swift. I've heard of her. I wouldn't recognize her on the street, but I have heard of her. Taylor Swift is the 97th percentile in height for young women. The 97th percentile. The mean is 65 inches, and the standard deviation is 2.6 inches. Okay, and she is at the 97th percentile. All three of those are pretty important pieces of information, would you say?
Yes.
Okay. So let's first make a sketch of the normal distribution. What number goes right in the center?
65.
65, right? The mean is right here in the center, correct? What number then goes one deviation to the right?
66?
No.
67.6.
67.6, because they told me how far to move to the right to go one deviation.
Okay, so you add 2.6 to 265.
Yes, because that is the standard deviation. And what's going to be over here?
69.
6. Yeah,
62. 70.2.
69, no?
Now, if you add 2.6 to 67.6, you get 70.2.
Sorry.
Oh, if my math is off, but it's not. And then if I add one more?
72.8.
72.8. Now, if I go the other way.
63 point.
That's right. Confidence. Yeah?
It's 62.4.
62.4. And then the next one.
59.8.
How much?
59.8.
59.8. And then the next one.
57.2.
57.2. So where is her height on this, the grand scheme of things? She's in the 97th percentile. Where do you think she lands approximately? Doesn't gotta be perfect, but give me ballpark. Where does she land approximately?
She's on 70.
Without looking at the chart?
Without looking at the chart. Just where does she, I mean, knowing that she's in the 97th percentile puts us where in this bell curve? In the middle, on the left, on the right?
On the right?
On the right.
On the right. Would it be like just barely on the right, moderately on the right, really on the right?
Really on the right.
Really on the right. She falls somewhere around here or so. Okay, she is in the 97th percentile. That means 97% of all the data is going to be to the left. So let's actually find her height. To do that, we got to go from the percentile. So we got to start with the percentile, which was given. From the percentile, we're going to calculate her z-score. And then from the z-score, we're going to calculate her actual height, x.
All right, so the first one,
Yeah.
I forgot.
Well, let's go to the chart. She's in the 97th percentile, right?
Oh.
So which z-score, approximately at least, corresponds to the 90th, sorry, Daisy, I'm sorry to hear that. But which z-score corresponds approximately to the 97th percentile?
1.9.
So yes, certainly somewhere between 1.8 and 1.9, right? Seems to be a lot closer to 1.9 than 1.8, right? So let's just say 1.88. I'm going to go to my calculator here and do it on my calculator. I'm just curious, 0.97. 1.88079,361. So 1.88 seems like a really good value to use. Okay. So from the sketch, we see that her z-score is 1.88. How do I get the x value from the z-score?
The x
The formula?
value.
What formula?
The z-score?
Okay, so what do I write?
65 minus, no.
Oh, wait. 65 is the mean.
X minus 65
X minus 65
over 2.6.
over 2.6.
And then you multiply each side by 65.
And then no, not by 65.
2.6.
By 2.6. So I get 4.89 equals x minus 65. So that x is equal to what?
X minus 65, x equals 69 point. That's deep.
12, 24, 36, 48, 60. That's 5 foot. That's almost about 5'10".
Yes. Makes sense.
So she's about 5'10".
She's tall.
She is tall. She's in the 97th percentile. Not only is she tall in regards to women, obviously, but I think she would even be above average when it comes to men.
Most definitely.
Okay. This is just another example. Okay, let's go to t-scores. Okay. So students and parents find a z-score, such as, for example, negative 0.5, difficult to understand. We understand it completely, right? What does a z-score of negative 0.5 tell us?
It's negative, that far off from the standard deviation.
So be more specific. Don't use words like that far off.
Half, negative to the left.
Negative 0.5, yeah, what is it? This is my lunch, by the way, guys.
What is it?
Cinnamon sugar sticks.
Not a good move there, Professor.
They call them, no, this is on the diet. They call them cinnamon sugar sticks. But this is 100 calories. This is my...
I have a question for you. Do you pay for your meals so you can go on, so you're on a diet?
It's like $400 a month.
You poor soul.
It's horrible.
But you know, my cousins did that and he lost a lot of weight.
Cool story, bro. Okay, so Lori.
Yeah.
You were saying a z-score of negative 0.5 means what?
It's a negative halfway from the, no, falls below the mean halfway. No.
Halfway to what? What does that mean, halfway? Halfway to what?
Well, hold on a minute.
Well, hold on 2 minutes.
Oh, from the standard deviation.
No.
No.
I mean, you were so confident. I really kind of felt bad shooting you down there, but yeah, that's right.
I'm tough. Falls below the, no.
Nope, try again. Anyone else want to jump in? Save Lori? Or you gonna
Save me.
You're all gonna let her flounder there.
They're letting me drown.
Is it the z-score?
Angela, I can't believe you're letting her do this, huh?
Is it the z-score?
Well, it's a z-score of negative 0.5. I'm asking what that means. If you go and your kid is tested and they say, yeah, your kid got a z-score of negative 0.5, and you say, oh, okay. What does that mean?
Is
negative
that the percentile?
No, not even close, but thanks for playing. Try again tomorrow. So z equals negative 0.5.
Isn't it just
proportion?
half a step to the left from the mean?
What? Say again, is what?
Is it not just half a step to the left from the mean?
What do you mean half a step? What's a step?
Like instead of a full standard deviation, it's half?
Yes. So if this is my chart, I'm here. I am 1/2 of a standard deviation below the mean. That's exactly what negative 0.5 means. I am 1/2, 0.5, 1/2 of a standard deviation below the mean. That is what a negative 0.5 means. But students and parents find that difficult to understand. So what we do instead is we calculate what's called a t-score. How do we get a t-score? Well, unfortunately, we need better vibes. I'm sorry, I'm a horrible vibe person. I will work on my vibes. Okay. But what we do is we first calculate the z-score. You first calculate the z-score. You multiply that by 10, and then you add 50. Okay. This is the formula for a t-score. Okay.
Will it be 55?
For this example here?
Yeah.
Well, what's 10 times negative 0.5?
Negative 5.
Plus 50?
Also be 45.
It'll be 45.
Sorry, I did not realize it was a negative.
I forgive you. I forgive you. Okay. So the first question we have is, what is the mean and standard deviation of t-scores? What is the mean? Look at the chart there.
50.
50 is the mean. And what's the deviation?
10, 20.
Negative 0.5.
No. Look at the graph.
10.
10.
10. The mean is 50. And the standard deviation is
Getting hung up.
okay. So let's do an example. Scores on the Wechsler Intelligence Scale for Children, the WISC-4, are normally distributed. That's nice to know, because that means I can use my bell curve. They're normally distributed with a mean of 100 and a standard deviation of 15. What is a t-score if a child has a 75 IQ? What is a t-score for a 75 IQ?
So we take, wait a minute, 10.
We'll wait 2 minutes.
I have a question. With the 75 be the x, so it'll be 75 equals x minus 100 over 15.
75 is not the z-score. 75 is your actual score.
So we
Lori,
have to,
Lori, Angela asked
happened?
you a question.
Oh, wait, what? Oh, Oh, I'm glad you asked. I am drinking Italian roast, Starbucks coffee out of my estate sale. Lucky Cup coffee. Isn't that just the cutest mug you ever saw?
That is so cute, Lori.
Yes, Lori,
love
that is very
this.
cute.
Do we have other estate sale people?
No, but I wanted to ask you, how do you get into those?
Oh, you just go. You just show up.
But like, how do you know?
Oh, estatesales.net.
Got it. I see a lot of videos and I've always wanted to go to
Oh,
one.
dude, you got to go. It's
Class outing. Class outing. Next estate sale. We all go. We all go.
I'm
I
taking my
know.
son to a pumpkin patch after class. You guys want to come?
Oh my gosh, that
I
sounds
have my
awesome.
own. I have my own pumpkin here.
That's like, come
I gotta
on,
get rid of it and then carry it around like all those pictures. You know, I'll show you how
Me
much
and Angela
I
just
lost.
carved pumpkins and an animal ate my pumpkin.
Uh-oh. What kind of animal?
I'm not really sure.
Uh-oh.
I'm
Maybe
gonna
a
about animals.
possum.
Would you like us to come shoot that animal?
What?
Wow.
Where are the pumpkin patches? That's a good question. Someone needs to throw a quarantine party. Yeah, I think that would defeat the purpose, but I'll get right on that. Okay.
I have two questions. Sorry, before we get back to math.
Yeah.
One,
Get back to math. It's all about math. What?
Okay.
Never
First
all
thing,
about math.
we never did show and tell.
Yeah.
Oh, my
Second
food.
thing, Halloween is on Saturday and nobody came in their costumes.
Oh my God, I forgot.
So I said what I said. Thank
Well,
you for that.
I'm dressed as a middle-aged man in a midlife
Come on,
crisis.
put
How
your
about
hat
you
on,
guys?
Angela.
Oh,
Crystal, my Halloween plans are to take my son trick-or-treating if I can.
Better
That's your
go
costume?
to Santa Clarita.
You're wearing
I
a hat?
guess.
That's your costume?
My
Yeah,
Halloween,
we're
did not
cowgirls.
touch me.
Oh,
Crystal,
from
I said that, shooting the animals. It was Miriam.
so you're gosh, what the heck is your name from Toy Story? Dang.
Yeah, we're Woody and Jesse.
Woody and Jesse.
We are also rat moms.
Oh.
We have a rat. We're gonna get a rat. We'll keep you
Um,
updated.
Yeah, I have a special like ability where animals just like feel like comfortable with me. So for example, squirrels,
Like a
I can get
hyena?
them to come up to me. And lizards, I leave them tomatoes in my front yard and they come up to me as well.
That's amazing.
I think I'm an animal whisperer.
We can get back to
I think
math
you're
now
right.
if you want.
Yeah.
Oh, but I was going to answer the question. So the first step I would think to do, so you have the mean, which is 100. You draw a little bell, and then you have 115, 130, 85, 85 minus 15. If someone wants to help me with that one.
Hopefully no one has to.
I just want to give people the chance to talk.
That sounds very sweet. You're doing a great job.
130.
So, how do I find the Z-score? You can't get to the T-score until you get the Z-score.
I hate
What's
when
the
that
formula for the
happens.
Z-score?
I gotta keep looking back. I don't have it memorized yet,
Oh, is it
Professor.
75 minus 100 over 15?
Boom. 75 minus
Yes,
100 over
Miriam.
15. Awesome. Now, what is 75 minus 100?
Negative 25, Bob.
Over 15?
Oh.
Who the hell's Bob Ross?
It's like
So the answer is -1?
It's like a game show host situation. Is my internet? Wait, what's happening? We lost him.
Lost who?
Oh,
Me?
I thought there was some internet issues over there. Okay, so
By the way, I'm working on a magic trick. Ready? I'm going to grab something out of thin air. You ready for this? Ready?
no way.
How'd you do that? It was behind your hand all this time.
PSA, if you look, this is Bob Ross. I don't know if you can see.
Hey, he's got my hair.
Anyway,
So, do
thank
it
you.
again.
It's not quite your hair, Professor, but okay.
Well, you know, it was at one point. Anyways, so our z-score is negative 1.6 bar. Okay, our z-score is negative 1.6 bar. Now,
All right, so
how do I get,
now
now that I have the z-score, how do I get my t-score?
10 times negative 1.6 bar plus.
Is it 66.6 bar?
Let's take a look. We take our z-score, which is negative 1.6 bar.
No, I lied. No, no, no. Mine was positive. I lied. Don't listen to me.
Too late. Times 10. No, is it times 10? Yeah.
Times 10.
Plus 50, right?
Plus 50.
Okay, I have a question. How would you multiply the bar? Will it just be negative 1.6?
No, what I do in my calculator, I put a negative 1.666666666. I just put lots of sixes in.
The answer is 34.
So the answer is what?
34.
33.3
Wait.
bar.
I'm confused. Are you serious?
Yeah.
I got 34.
Okay.
Did you do negative 1.6?
No, you're
Or
right.
did you do negative 1.6 bar?
No, I forgot the bar. Sorry. Brain fart.
Bar, you can't forget the bar. You can't do that.
Question.
Yeah.
So for this t-score, we don't use the chart that you gave us for the z-score.
No. You first
All right.
gotta get the z-score. And
Yeah,
then
but
once you have the z-score, then you get the t-score.
No, but I'm talking about that graph that you gave us with all the numbers.
Yeah, that's how you get the z-score. Well, no, you don't need that one. That's the percentile. That's the percentile. That's the percentile. Okay.
Do not use percentile chart.
You don't need it for this example. You don't need it. Okay. Now, question. If your t-score is 40, what's your z-score?
You divide by.
I'm having too much fun. Yeah, you divide by what? Well, don't divide by anything. Start with your formula. What's the formula for t-score? T equals
well, that'd be too easy. Okay, so 10.
Let's try the easy way out. Huh?
10 times.
Times z plus 50. Right? That is the formula for t. T equals 10z plus 50, right?
Yeah, so now it's 10 times, my gosh, negative 1.
No. That's a whole different example.
Z will be 9?
You subtract 50 from both
10
sides.
times 9 plus 50 is 40?
No. Sorry. 20.
Subtract-
Z will be 20.
Subtract
20 is
50 from both sides.
Subtract 50 from both sides. What do you get?
You get a negative 10.
Equals 10.
Negative 10.
Equals 10z.
10z. Divide both sides by 10.
And you get negative 1.
Equals
magic.
Magic like this. Oh, that didn't work. Crap.
Wait, I'm having,
You can smile, Yesenia.
40. Why did you put 40? Oh, a t-score of 40. So that's the t.
I am
equals.
impressed,
Okay.
but my head hurts, so I look like a bitch right now, and I'm so
language. Oh my God. Okay, what do you have? RBF?
RBF.
When I have a headache.
Okay, fair enough. I have a headache too, all the time.
I don't. I look like this all the time.
Okay, so we have a z-score. Now, what was the actual score?
Now you go into the.
No, don't need the chart.
X would be 40.
No.
She's going to do karaoke for us now.
Ooh, yeah. Math is great. Math is amazing. Our professor makes it fun.
Just remember something, guys. This is going on YouTube. The whole world will see this eventually.
This is our moment.
Yes.
How do I get X from
They're
Z?
gonna ride your clout. That's why.
That's amazing.
How do I get X from Z?
Oh, let's see. So we have the Z-score and we need the original. No, what is that we need? What's the question again? What score do you need? Sorry.
No, what if you got a T-score of 40, which is a Z-score of -1. I'm asking.
T-score is -1.
Me? Cinnamon sugar sticks.
X minus X bar.
What are they made of?
Divided by standard deviation.
Gross stuff. More gross stuff. And there's some gross stuff.
Is there any cinnamon?
How did you do it, David?
Huh?
I went with the Z-score formula, X minus X bar divided by SD.
What's X bar?
X bar is the mean.
Which is what here?
It's -1 minus 100.
No. -1 is my Z-score, not my X.
Oh, -1 minus 100.
No, -1 is my Z-score, not my X.
Oh.
Z equals X.
So X equals
over standard deviation.
That's what I meant.
You can't mix and match these things. Everything goes in a very specific spot.
So now we have to find X, right?
So now we have to find X.
So we're going to multiply by 15.
Okay.
So 15
Is
gets
it
rid of the
85?
85.
Ding, ding, ding,
Which
ding.
makes sense because remember what a Z-score of -1 is? You're 1 deviation below the mean. If the mean is 100 and you're 1 deviation below the mean, you're 15 below the mean. You're at 85.
1 deviation. We've gone full circle. 1 deviation below the mean.
1 deviation below the mean.
And the mean was
Just so I'm clear, you plug
100.
everything back into your formula. If you're trying to find the Z-score, if you have the T-score, you just plug everything back in to the Z formula to get.
T has a formula to Z. Z has a formula to X. Z also has a formula to the percentile from the table. So Z-score is like the center. If you make a little chart here, from Z, I can go to T, I can go to X, and I can go to my percentile. So the importance of Z is so big because from Z, you get everything. I have a formula to T, I have a formula to my data, X, I have a formula to the percentile, or at least a table to get from the percentile. So the Z-score is really such an important aspect because everything connects to it. I don't go directly from T to X, from T to ear, from here to ear. Go through Z, collect $200. Or do not pass Z. I don't know. I just made it up.
You know, you just drew the flux capacitor, right?
I drew the flux capacitor. It's what makes time travel possible.
Yes, possible.
What's the flux capacitor?
Oh my God. Lori, what is wrong with you? You don't know Back to the Future?
I said I'm done. I'm leaving.
The movie Back to the Future?
Gosh, boring. I'm sorry.
Boring?
Finally, someone said it.
Class is over. I am not coming back.
That movie is awesome. The movies are awesome, actually.
No, but actually, I worked at the house where the beginning is filmed at. That's kind of cool. It's in Pasadena.
Really?
Catered a party there.
I thought it was in Hill Valley.
Lori, you do catering?
I do. Not
Really?
a lot
You're
right
catering?
now. Not right now so much, but I'm trying.
Is it because of COVID? That's why?
You
Yeah.
send me real food because this stuff sucks.
Dude, that stuff is too much like preservatives. I have a great eating plan, but anyways, I make pasta. Yes, I make everything.
Can you come over and cook for us?
Yes.
Yum.
For a small fee.
Halloween quarantine party.
Wait.
Wait.
I love pasta. What kind of pasta do you make?
Anything. Anything. anything.
You guys,
Do you make
I make
lasagna?
balloon arches.
I love my lasagna. I only
Oh my
like
god, I would
my
love
lasagna.
it too.
Okay,
And-
this is what we're gonna do. Lori's gonna make lasagna. I'm gonna make a Halloween balloon arch.